Hi everyone! Today's topic is squaring and 2 by 2 digit product. You can do multiplication correctly and quickly with the convex block. Okay, let's get started. This multiplication consists of 4 parts. 40 times 80, 3 times 80, 40 times 5, 3 times 5. Then removing these zeros, put this 15 here. Call this shape convex block. Also this. Another convex block. I'll show you how to use them. Left times left, in times in, out times out. 20 here, as in video 1. Then right times right. And the vertical sum. Once again, left times left, 0,8, in times in, out times out, 16 here, and right times right, and the sum. Next example. Left times left, in times in, 28, out times out, 28 again, and right times right. Here is 2 times 7 times 4. Knowing this, 7 squared, 2 times 7 times 4. 7 times 8, then 4 squared, and the sum. This is what we used. Once again, 8 squared, 2 times 8 times 3, 8 times 6, and 3 squared, then the sum. Once again, 6 squared, 2 times 6 times 9, 54 times 2. When it's hard to do it in mind, write 6 times 9 twice. Next example. Left times left, in times in, out times out, right times right. This 36 is 4 times 3 plus 4 times 6. You can do factorization as in video 3. Knowing this, 4 times 4, common tens place times 1's place is sum, 4 times 9. This is the common times the sum. Once again, 9 is common. Then common tens place times 1's place is sum. 9 times 5. Next example. When one's place is common, left times left. Common one's place times tens places sum, 4 times 10. The convex part is 4 times 3 plus 4 times 7. 4 times 10. Once again. 2 times 7. Common one's place times the tens places sum, 5 times 9. Next example. When having a twins, left times left. A twin times the sum of the known twins, 4 times 11. "44 is 4 times 3 plus 4 times 8. Both have 4. Once again. Left times left. A twin times known twin sum, 9 times 5. Next example. Without common tens place or a common ones place or a twins, get back to the basic way. Like 3 times 4, 4 times 4, 3 times 7, 4 times 7. 37 is 4 times 4 plus 3 times 7. Not 4 times 10. It works when common tens place or a ones place or a twins. Not for a common in nor a common out. Move on to mixed calculation. Left times left, in times in, 12 this time here, as in video 1. Then out times out, 6 times 7, 42 here. Then right times right, 4 times 7, 28 here. Then 2 times 8, in times in, 24 here. Then out times out, 08 here. And right times right, 12 here. Then subtraction. 8 is common. 5 minus 0. 4 is common. 2 minus 9. Then 8 minus 2. This is 50 minus 7, as in video 2. This notation makes mixed calculation compact, avoiding copy mistakes. Once again, 7 times 5, 3 times 5, 7 times 6, and right times right. Then 4 squared. 2 times 4 times 9. 8 times 9. and 9 squared. Then the sum. Here is 10, 18, another 10, 14, 24. Move on to team product with one sum product, like 1 times 1, 2 plus 3, 2 times 3. This is what we did. Once again, 1 sum product. Once again, 1 sum 10 product 21, 221. Once again, 1 sum product. This is 32. Go to video 17 for ternary. Once again, 1, 3 plus 3, 3 times 3. Knowing this, 1 twice squared. Once again, 1 twice squared. Once again, 1 twice squared. It's 28. Once again, 1 twice squared. It's 36. Move on to reverse squaring. When a number less than 10,000 is certainly an integer squared, you can find the integer easily. First, take the 2-digit as 68. It's under 9 squared, but over 8 squared, so maybe 80-something squared. And the number has 9 in ones place, so the integer's ones place is only 3 or 7. Look at these 1-digit square numbers. You can forget this table, but just remember, the sum of possible pair is 10. It is from 9 being 10 minus 1. It's hinge 121. Also 81. Neg 1 squared is 1 squared, as in video 4. 8, 7, and 6 are hinge 12, 13, and 14. A negative squared is the same as a positive squared. So let's try 3, as we did. We got it. Next example. 5 squared is too much, so maybe 4. Then 1's place 4 means 2 or 8. Since it's close to 25, let's try 8. We got it. Once again, 0.3. 2 squared is too much. It's 1. Then 1's place 1. Not 11 squared. So maybe 19. It's done. Orientation. Reverse squaring can be used also for a factorization. Go to video 21 for the details. Move on to 3-digit squaring with this pyramid, like 4 squared, 5 squared, 3 squared. Then product 452, 532, and 432 here. Once again, 999 squared, 81, product 992, 162. The same product compressed. Another one on the top, and the sum. You can do it with double 81. This is the giant pyramid for 4-digit squaring, just for fun. Okay, let's move on to the drill. This video continues in video 11. Okay, thank you for watching. See you next time. Bye.